Welcome back to this next part of week 3 on developer tools and workflows. In this session, we are going to focus on an essential tool set for any modern developer, Git and GitHub. These tools are fundamental in the world of software development, not just for managing your own work, but also for collaborating with others on small and large projects alike. By the end of these sessions, you will clearly understand what Git is, why developers across the world rely on it, and how platforms like GitHub or GitLab enable collaboration in a distributed development environment. I will also walk you through the basic Git workflow so you will know how exactly to start using Git in your own projects. So let's begin with the basics. What exactly is Git? Git is a version control system. Simply put, a version control system is a tool that helps developer track changes made to the files over time. With Git, you can save versions of your work, go back and revert changes if something breaks, and collaborate with others without worrying about overwriting each other's work. Unlike some tools that require a connection to the central server, Git works locally on your machine. It quietly keeps track of the history of every change in your project directory, allowing you to manage your code with confidence. Now, this often leads to some confusion. What is the difference between Git and GitHub? Git is the underlying tool, the actual version control system that keeps track of changes to your files on your local machine. It helps you manage the history of your code, work on new features without disrupting the main code base, and safely experiment with changes. GitHub, on the other hand, is a platform that hosts your Git repositories in the cloud. GitHub and also GitLab add collaboration features on top of Git, such as pull requests, issue tracking, continuous integration, and deployment tools. Think of it this way. Git is a tool you use on your machine, and GitHub or GitLab are the places where you share your work with others and collaborate as a team. GitHub is widely used across the industry, while GitLab is also popular, especially when teams prefer self hosted solutions. Now that we understand what Git and GitHub are, let's go through the basic Git workflow. When you start a new project and want to keep a track of it using Git, you begin by initializing a Git repository. This is done with the command git init. Running this command in your project directory creates a hidden .git folder. This hidden folder is where Git stores all the information about the history of your project, or your commits, branches, and other versioning data. Once your repository is initialized, you can check the status of your repository project at any time using git status. This command shows the current state of your working directory and staging area. It tells you which files are untracked, which ones have changes that have been staged, and which ones are staged and ready to be committed. When you make changes to the files and want Git to track those, you use git add command. This moves your changes into the staging area, preparing them to be committed. You can specify individual files or simply use a period to add all the changes in the current directory. Once your changes are staged, the next step is to commit them. Using git commit, you create a snapshot of your project at that point in time. Commits require a message, and this message should briefly describe what changes you have made. Over time, these commit messages form a useful history of your project's development. You can always look back at the history of your commits using git log command. This shows all your commits on a current branch, along with the details like commit message, the author, and a unique commit hash. This history allows you to trace when and why changes were made. After understanding these local operations, it is also important to learn how to configure Git with your identity. This is done with two simple commands. First, you set your username with git config --global space user.name, followed by your name and quotes. Then you set your email with git config --global user.email. These settings ensure that every commit you make is correctly attributed to you. You can verify your settings at any time with git config --list. These configurations are stored in a config file on your system and apply globally in all the repositories you work on. Next, let's explore the concept of remote repositories. While Git works locally, you often need to share your work with others or keep a backup in a cloud. This is where GitHub or GitLab comes in. You start by creating a new repository on one of these platforms. Then you link your local project to this repository using the command git remote add origin, followed by the repository's URL. Once the connection is set, you can push your local commits to the cloud with git push -u origin main. This uploads your code to the main branch of your remote repository. If you need to bring down changes made by the others, you use git pull. And if you want to start working on someone else's project, you can clone their repository with git clone, again followed by the repository URL. This ability to push and pull code enables teams distributed across the world to collaborate on the same code base efficiently. Now let's reflect for a moment on why developers rely on Git so heavily. First and foremost, Git makes collaboration seamless. Multiple people can work on the same project simultaneously without stepping on each other's toes. Through features like branching, everyone can work on their own version of the project and later merge their changes. Secondly, Git maintains a detailed version history, recording every change that has been made. This gives you the ability to go back to any previous state if something breaks. Thirdly, having your project pushed to a remote repository acts as a backup, safeguarding your work even if something happens to your local machine. Additionally, Git and platforms like GitHub are the backbone of open source contribution. Developers across the globe can fork projects, clone repositories, and contribute improvements. Finally, Git makes experimentation safe and easy. You can create new branches to try out new ideas without risking the stability of your main code base. In this demonstration, I will give you some GitHub UI basics, which will include how to fork a repository, how to start a repository, how to create a pull request, and how to create issues. For that, you need to go to github.com and sign in into the account or sign up into the account. So if you do not have an account, you can just sign up. If you have an account, you can sign in. Once you sign in, you will be redirected to the dashboard, which will look something like this. So it will give you some updates of the GitHub and some other files on the top. To go to any repository, you can search for a repository on the search bar here, or you can find your own repositories. I'll be going to a repository called OctaCAD Spoon Knife. This is a demo repository for GitHub. Now, what do you need to observe here is that on the top left, you will see the username and the name of the repository. Right at the bottom, you will see some important headers of GitHub UI. Things like code, issues, pull requests, actions, and so on. When you go to code, you will see the entire structure of the code along with the README files, which is written in the form of Markdown. The second part is the issues. The third part is the pull request and other things that we're going to cover today. So if you like the repository, if you find the repository interesting, what you can do is you can star it on the top right. If you click on the star, it will be starred. The number on the right will tell you how many stars this repository has. So this kind of gives you an idea of how popular the repository is. Now what we will do is fork this repository. Yeah, if you see right below, right before the star part, you will see this option to fork. When you fork a repository, what GitHub does is it creates a copy of the project as your own. So you will now be able to get this repository as your own with the name, your user ID / the repository name. When you click on create fork, it will create a repository of your own. So basically what it does is it creates a copy of the same repository which you can refer. Now the main objective of doing that is if you want to make some changes to this repository, you can then make the changes and then create pull requests for it to be merged to the main repository or the original repository. Now let's say if I want to make some change or suggest some change, I can just make the change and create a pull request. So let's say if I go to readme.md, let us open readme.md. On the right, we can edit this file by clicking on this pen button. And here on the top, we can just make a change. Let me see if I can zoom this. Yeah. So here I will just write a change. This is a change for demonstration. Once you feel that the change is done, now since I have done this change in the README file, it will show in the README file, but you can make change. Similarly, you can make change in any other file of the project. To make a change in your own repository, you can make a commit, right? So it kind of gives you a suggestive commit message like update README, and you can just write an optional extended description. You can leave it if you want. Once you're done with create commit, what will that do is create a pull request to the original repository. Okay. Now, if you feel that there is some change that you can do or there is a feature that you can suggest, you can create an issue. To create an issue, you can just click on create and click on new issue. When you create a new issue, you can just write the name of the issue. For example, you can just say there is a typo in the HTML file. Okay. You might add some screenshots here or write the description. I can say the head tag is spelled incorrectly. Now, this may or may not be the actual issues that you want to say. I'm just giving you a demonstration. Once you're done with this, you can just create the issue. Once the issue is created, it will be shown to the developers of the original repository, which they can address and later on take this as a change. So as a result, what we have seen here, we have seen some basic features of GitHub UI, that is the username and the repository name, some features like where to see the code, how to create pull requests, and how to create issues, and then how do you star a repository. With this, you will have some basic understanding of GitHub UI. Okay, now let's move back to the slides. GitHub and GitLab are platforms that host Git repositories online and provide collaborative features to make teamwork more efficient. Mastering the basic commands like init, add, commit, and push is crucial for any developer. Remote repositories play a vital role in enabling collaboration, provide backing up, and enhancing period visibility or project visibility. If you aim to be a software developer, proficiency in Git is not optional, but it is foundational. With that, we will end this session. Thank you for following along in this session. In this next part, we will continue to build on these tools and workflows to make you effective and confident in managing your software project. Thank you.